welcome to the uni-max workshop. Torque has been my favorite quantity since my high school days. The teacher asked what a tight pen is for on the wing, and a classmate quickly replied that the pen is there for a moment. We won't dissect engineering tables for pens, but we'll look at useful tools related to torque, specifically torque wrenches and other devices for precise and comfortable tightening. What are torque wrenches actually good for? For important bolt connections, the tightening torque is specified, and for structural and safety reasons, it's good to adhere to it. A threaded connection is indeed a connection with forced contact, and sufficient friction to prevent the connection from loosening occurs only at a certain tightening torque. Additional tightening does not mean higher safety. On the contrary, it leads to unnecessary stress on the connection. In extreme cases, it can even lead to thread destruction. So, it's not good to tighten too little or too much, but just right, and that's where the one above helps us. Look at that, a torque wrench. In industry and craftsmanship, there are countless cases where the use of a torque wrench is required. However, we also encounter the need to adhere to tightening torque in everyday life. Probably the most common is tightening the wheel bolts on a car. Less well known is the need for precise torque on bicycles, but also, for example, on the cutting blades of lawn mowers. There, it's even a double-edged sword. The accuracy of the tightening affects not only the strength of the connection, but also the functionality of the shear coupling. If the screw has such high friction that when the blade hits an obstacle, it does not rotate on the shaft and cut through the pins. The shaft absorbs the impact energy, and it can lead to damage of a more expensive component than the drive with the safety coupling. Torque wrenches powered by human strength are divided into mechanical and electronic. In reality, all of them are mechanical. The electronics only provide more convenient operation. Both types have their advantages and disadvantages. A mechanical key can be bending, screw, or torsion, and probably the most widespread so-called. The ratchet with a proven spring mechanism and a pawl is the most common. When a set torque is reached, the pawl will skip and tightening will stop. Electronic wrenches and adapters use a torsion mechanism, which is more precise than bending and ratchet types. However, its disadvantage is the need to monitor the indicator on the scale and to stop tightening when the desired torque is reached. The analog to digital converter not only allows you to monitor the current value on the display, but it can also acoustically warn you as you approach it and when you reach it. Unfortunately, just like a purely mechanical torque wrench, it cannot prevent further tightening, so you need to work slowly to stop the tightening in time. Digital displays can either be part of the torque wrench itself, or there are torque adapters that can be inserted between any wrench and the nut. They come in sizes for the most common 1/4 inch, 3/8, and 1/2 inch drive. Generally, the torque range is also determined by the size of the drive. Personally, I would get both types. With the electronic adapter, you can also check the accuracy of the ratchet torque wrench from time to time. The adapter is more versatile, but it's more convenient to use a classic torque wrench for wheel bolts. For the mentioned bicycles, there are torque wrenches with the appropriate range of torque values, since these are low values. In this case, from 1 to 8 Newton meters, the wrench is designed in the form of a screwdriver. You might be surprised by the amount of force required for 8 Newton meters with a lever arm corresponding to the diameter of a screwdriver handle. It's about 1 inch, so divide 8 Newton meters by 0.000254 meters, and you'll find that you need to exert a force of 315 Newton meters, which is equivalent to the weight of over 30 kilograms. At that moment, you'll appreciate a practical torque multiplier, which increases the lever arm and thus reduces the required force. For small torque values, you can also use an adapter for 1/4 inch ratchets. However, it only works from 5 Newton meters. And finally, one more tool for tightening, an angle adapter. Some connections require not only a specified torque, but also a specific angle by which the screw or nut must be turned after a certain tightening. You will mostly encounter this in the automotive industry, for example, when tightening the bolts on a cylinder head. And just like with torque wrenches, there are either purely mechanical or mechanical electronic devices. You must use the mechanical variant together with the torque wrench, while the electronic adapter measures both torque and angle simultaneously. My name is Tomasz Krasinski. Thank you for watching, and we'll meet again in the uni-max workshop.